Hey Raju, which topic is taught to us yesterday? I was absent.
Sir has started a new chapter, Instrumental Methods of Analysis. It is totally new concept to us.
Oh, I missed it. What should I do now?
Don't worry Pooja, I will show you that recorded video.
Hello friends, welcome to our channel Chemistry with SK. Today in this video, we will see the concept of chemical analysis. What do you mean by analysis? The chemical analysis is nothing but the study, or we can say investigation. So the chemical analysis is of two types. One is qualitative analysis and other is quantitative analysis. What do you mean by qualitative analysis? Where we study the quality. What do you mean by quality? So quality is nothing but the parameters related to the content or composition. It means if you are knowing the details related to composition or content, that is said to be the quality parameters. Okay. Then another is quantitative analysis, where we measure the quantity. It means the quantitative analysis is nothing but the study of amount or quantity of various components present in a material. So it is called as quantitative analysis. So the quantitative analysis is of again two types. One is said to be volumetry and other is said to be gravimetry. So what is meant by volumetry? If you are measuring the volumes, if you are studying the volumes, then it is said to be volumetric analysis. And other is gravimetry. So what is meant by gravimetry? It is nothing but the parameters related to the mass or measurement, the quantity, the amount. The amount is determined in the grams or mass. It means if you are measuring the volume, it is the volumetry. If you are measuring the mass, it is said to be gravimetry. Let us see the advantages of instrumental methods. As we have seen in your previous classes from school levels or in 11th and 12th class, you might have studied about the regular titrations. So whatever the titrations you have studied, we have to see now instrumental methods. But before starting our chapter, that is instrumental methods of analysis, we need to see some parameters or we need to recall previous knowledge. So what are the benefits? They give accurate results. The results are faster and quick. The sensitivity is also more. The instrument can detect even a small quantity of samples. The instrument can detect very small amount of substance from the given sample. It means though it is present in very small quantity, minute quantity, still we can detect it by using such instrumental methods, and that is the beauty of these techniques. Equivalence point can be determined instead of endpoint. Now it may not be clear to you. You might not know the concept of equivalence point and endpoint, because practically you have determined endpoint in the school levels and in junior colleges. So what is difference between endpoint and equivalence point? That we'll see. But before that we'll see few more points. No indicators are also required here in this particular case. So when we are performing the instrumental methods, there is no requirement of indicator for the titrations. Okay. And weak electrolytes can also be tested very correctly. Why it is the advantageous point? Why it is a beneficial point? Because by using normal titration, it is not possible to study weak electrolyte or the titration of weak electrolytes, because they do not give sharp change in the color. With the help of instrumental methods, the weak electrolyte can also be tested. So let us see the difference between traditional titrations and instrumental titrations. So as you know, in traditional titration, we require some instruments like burette, the conical flask, while in instrumental methods of titration, we also require burette. Instead of conical flask, we are taking beaker. Why we need to take beaker here? Because here if you are taking conical flask, then this electrode cannot be placed, because we need to dip some electrodes. Okay, suitable instrument depending on the instrument used. So the electrode should be fitted in that, electrode should be fixed in that, and therefore we need to use beaker instead of conical flask, because the conical flask will have small neck and the electrode cannot be fitted properly. Therefore we are taking the beaker. So we know that we are using indicator here. Burette is filled with NaOH solution, and in conical flask we have taken 10 ml of HCl solution. We are using phenolphthalein as indicator. So suppose we are performing this titration in traditionally. Now if you compare the same titration in instrumental way, what will the difference? Here also the same solution we have taken, that is NaOH solution is taken in the beaker. Phenolphthalein is not used as indicator because there is no requirement of any indicator to use, and we are also taking HCl solution. So here whatever the solutions we have taken in the burette and conical flask, that are almost same. What is the difference? Here we are not using instrument, while in case of this we are using some instrument and some electrode. We are using indicator here, we are not using indicator in the instrumental method, right? So these are the major changes in the instrumental part. Now let us see what is difference between endpoint and equivalence point. Okay, so let us consider that we have taken 10 ml of HCl in conical flask and we are titrating it in traditional way. Okay, so what we are adding? 10 ml of HCl solution. Let us consider this is HCl molecule 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the 10 ml of we can say 10 molecules of HCl solution, and we are adding NaOH solution from burette. So what will happen? So let us see what happens exactly and why the endpoint is obtained. When the burette solution is added, that combines with the solution from conical flask, that is HCl solution. So there will be HCl and NaOH reaction and there will be neutralization of that. So as we are adding NaOH solution from burette, there will be neutralization reaction and there will be salt formation. If we add second molecule, that will combine with another molecule of HCl and there will be neutralization reaction. In this way, each molecule which is being added from burette, that will react with the conical flask solution and there will be neutralization. So in this way, there is a decrease in concentration of HCl solution whatever we have taken. Okay, so whatever HCl molecules we have taken in the conical flask, that are going to decrease. So in this way, step by step, there is a decrease in concentration of HCl solution and one stage will reach at which there is a last molecule of HCl remaining. So when that last molecule of HCl will react with the burette solution, at that time that will react and there will be neutralization, complete neutralization. And this particular point is expected to be written or to be reported as a reaction completion point, and that can be called as equivalence point. But unfortunately, it is not possible to identify equivalence point by using traditional titration, because we don't know whether this point is reached or not. What is our role? We are just observing the change in color. Still there is no change in color. The solution is colorless itself. Okay, there is no change in color. So the next drop of burette solution will react with the indicator and there will be a reaction and there will be some product formation by the indicator and this NaOH, and that's why the solution will appear as pink. Thus we call it as endpoint, but the reaction is already over few drops before, right? And we need to find out that particular point as accurate point, which is not possible by traditional way. So what we are observing? We are observing the change in color which is observed now. Okay, so it is called as endpoint. So in this way, this is the main difference between equivalence point and endpoint. Let us see with the reactions. So the reactions taking place, as we know that HCl and NaOH are reacting together and there will be neutralization reaction. NaCl molecule will be formed and these reactions will be taking place up to equivalence point. Both the solutions are colorless. When all the HCl molecules will be finished, at that time such reaction is not possible because HCl is finished. So when we are adding extra drop of NaOH or next drop of NaOH, at that time there is no HCl to react, so that NaOH will react with the phenolphthalein indicator and there will be formation of some product which is of pink color, and that's why the solution appears pink and we call it as the endpoint. So in this way, this is the basic difference between equivalence point and endpoint. Okay, equivalence point is always smaller than endpoint. There may be a difference of a single drop, but there will be the difference. So let us revise. So by using instrumental method, we can find out the equivalence point by graphical method. We have to just plot a graph of the readings which are obtained on the instrument. So here when we are adding the burette solution in subsequent portions of 0.5 ml, at that time the solution will be mixed by using stirrer here, and this electrode will sense the reading and that will be displayed on the digital screen of the instrument, and accordingly we have to just plot a graph for getting equivalence point. So here we don't have to observe any change in color because no indicator is required. So you know that why indicators are added? To just observe the change in color. What will happen if you are not using indicators? Whether the reaction will not occur? Yes, the reaction will occur, but we will not able to identify whether the reaction is over or not. That's why we are using indicators in traditional method. But here there is no use of indicator or there is no requirement of indicators. So that's it for today. See you in next video. Thank you.